In our last video, we looked at how to do synthetic division with higher order polynomials. In this video, we're going to look at how can we use that synthetic division, use that division of higher order polynomials to find function values, to find factors, and to find zeros of the polynomial. So I want you to go ahead and do two synthetic division problems for practice here. Let's say that we do g of x is equal to x cubed minus 8x squared plus 17x minus 10. And I want you to divide by x plus 2. So I want you to do the synthetic division, get your coefficients of your quotient, get your remainder, and then I want you to write your answer. Go ahead and write your answer in the form we looked at last time. That was g of x equals what we're dividing out, the x minus k, times the quotient that we get, plus the remainder. So go ahead and do your synthetic division and then write your answer out in this form. Pause the video, do that work, and then start the video again. Okay, so we see that if I look at what I'm dividing by here, and remember I want x minus k. So in this case I have x minus negative 2. So negative 2 is the number I put out here. And then I have x cubed, x squared, x constant, so I'm not missing any terms. So I put my coefficients along the top here. And be really careful when you do this step so you don't make a mistake with a negative or a positive or whatever moving forward. Then to do the synthetic division, I drop the 1 down. Then I multiply negative 2 times 1 and add. Then multiply, and add, and then multiply again. Let's see, negative 2 times 37 is negative 74, and add, and I get negative 84. So if you did not get these numbers on the bottom here, go back, double check your work, then restart the video. Try to write your quotient, your g of x equals x minus k, q of x plus r. So g of x was the polynomial we started with here, x cubed minus 8x squared plus 17x minus 10 equals, and we see that we're dividing out x plus 2, and our quotient, what we get after we divide, we started with x cubed, so we go to x squared here. So we have 1x squared minus 10x plus 37 with a remainder of negative 84. Okay, I want you to leave quite a bit of space underneath this. We're going to come back and do some things with this. So let's go ahead and do practice another problem, and we're going to do the same thing. We're going to take what f of x is, what our given polynomial is, x cubed minus 16x squared plus 83x minus 140. And we're going to divide this one by x minus 7. So you go ahead and set up the synthetic division, do the division, and again, I want you to write this in the form f of x equals what we're dividing out, the x minus k, times the quotient plus the remainder. Pause the video, do that work, and then start the video back up. Okay, so we have x minus 7. That means we put a positive 7 out to the side here. We have cubed, squared, x constant. We're not missing any terms, so we have a 1, negative 16, 83, and negative 140. So we drop down the 1 and then we multiply and add all the way across. And we have 0 as our remainder here. So double check your arithmetic there if you don't have that answer. And then we're going to write out what we have here. What we're dividing, and then our quotient. And there is no remainder, so I don't have to put plus 0. I just don't have a remainder here. Okay, so that's practicing using synthetic division, getting a quotient. Now we're going to look at some different things that we can do with this same synthetic division. The first thing we're going to do is find a function value. And I'm going to find the function value at, or g, of negative 2. And notice that the negative 2 here is the same as what I have out here, negative 2. So if I did this the traditional way, if I were to find g of negative 2, what I would do is put a negative 2 in place of the x everywhere across here. But notice, if I did that, because g of x is equal to this, I could put a negative 2 here in place of this x, and then a negative 2 in place of all of this. And what I see is that g of negative 2, I'm not going to worry about what that is, but I see right here, negative 2 plus 2. That's equal to 0. So I have 0 times whatever this is, minus 84. So g of negative 2, all of this becomes 0, is negative 84. So I didn't really have to do all of this work. I didn't have to do all of that work. As soon as I knew that I was doing synthetic division with negative 2, I immediately know that g of negative 2, if this is representing g, is going to be my remainder every time. Every time. So we can use synthetic division to evaluate a polynomial at a particular number by doing synthetic division with that number, and my function value is my remainder. That's what's known as the remainder theorem. So I want you to look back at your problem that you did here, and I want you to find f of 7 using the remainder theorem. And we're going to see that when you do this, you are not doing any additional work. You're not plugging any numbers in. You're not doing any mathematical computations. You are literally just looking at your already existing synthetic division to find this function value. See if you can do that. And we see that using our remainder theorem, our remainder is our function value if the number here and here are the same. So our function value is 0. Let's go ahead and look back up here. Suppose I asked you, is x plus 2 a factor of g of x. In other words, does x plus 2 divide evenly into the original polynomial g of x? Does it divide evenly? Well, we can see whether it divides evenly or not by determining whether there is a remainder. And we see on this one, we do have a remainder, and it is negative 84. So that tells me no. X plus 2 is not a factor of g of x because I have a non-zero remainder. I can ask another question. Is negative 2 a zero of g of x? Is negative 2 a zero of g of x? In other words, if I plug negative 2 into the function g of x, my original function g of x, do I get 0? Well, we see right here, g of negative 2 is negative 84. That is not 0. So that tells me no. Negative 2 is not a 0 of g of x. And notice my answer for both of these is no. That will always happen. If x plus 2 is a factor, then negative 2 is a 0. If x plus 2 is not a factor, then negative 2 is not a 0. So I'd like you to look back at this problem that we did here, this division, and I want you to answer two questions for me. Is x minus 7 a factor of f of x? And is 7 a 0 of f of x? So pause the video, answer both of those questions with a yes or a no, and then turn the video back on. All right, is x minus 7 a factor? So we're looking right here. Does x minus 7 divide into my polynomial evenly? In other words, with a non-zero, with a 0 remainder. And we see yes, the remainder is 0, so I have two polynomials multiplied times each other with nothing left over. So my answer here is yes. X minus 7 is a factor of f of x. And then, is 7 a 0 of f of x? Well, my remainder is my function value. F of 7 equals 0, so 7 is a 0. Because remember, a 0 literally means the number that I plug into the function to give me 0. And notice again, yes, yes. If x minus 7 is a factor, then positive 7 is a 0. If x minus 7 is not a factor, then 7 is not a 0. Remember in an earlier lesson, we saw several statements that were always true. If one was true, they were all true. If a is a 0, then we know that f of a equals 0. That's literally what it means to be a is the 0 of f of x. We also know that the factor x minus a is a factor. Because if I set x minus a equal to 0 and solve for a, I get x equals a. So I know this one as well. And we also saw from our graphing in a previous lesson that if a is a real number, then a comma 0 is an x-intercept. So in this video, the previous video, we learned how to do synthetic division and get a quotient and a remainder to actually do the division. What we learned in this video was how to use that same synthetic division to find function values, f of something, what is that equal to? And that answer was a number, some number. We also found factors to see yes or no, something is a factor of a polynomial, and yes or no, is some number a zero of a polynomial. So for the rest of this lesson, if it asks you to find a function value, say f of -1, given f of x, we're just going to do synthetic division using the number, and notice we use the number exactly the way it is. Cube square x constant. Do our synthetic division. And then we know that f of -1 is equal to our number. Additional work. We can also answer the question, is -1 a zero of f of x? And we see we have a non-zero remainder, so our answer is no. Is the factor that goes with -1, which would be x minus -1 or x plus 1. So is x plus 1 a factor of f of x? And again, my answer is no. It did not divide in evenly. We had a non-zero remainder. So x plus 1 is not a factor of f of x. In our next video, we're going to look at